Hey everyone! In this lesson we're going to continue talking about how we classify living things into different sort of subcategories after we began with the broad categories that were the kingdoms of living things last time out. Now, I know there's been a week's delay between the last lesson and this one, and I do apologize for that, but hopefully we will be able to get back on track now, and we can use this lesson. I think this will be just part 2 out of 3, and then in the third part we'll talk um, a little bit about plants, but we'll see. I do want to spend some time talking about plants and what makes them different from animals. I mean, we know that they're different from animals and from other organisms, but it'll be useful to look at um, some of the really specific things that make plants unique, namely things like photosynthesis. So hopefully we'll get around to that. I'm just not sure whether I'll make that I'm not sure whether I'll structure that like a part 3 to this lesson or more like a lesson of its own that's just called plants. But anyway, we're going to get to that next time out. So in this lesson, we're just going to be focusing on discussing the animal kingdom, and when we're talking about classifying animals, the first step is to split them into one of two major categories, and those are the two categories that you can see on the screen there. That would be vertebrates and invertebrates. So those are this is basically this first division of organisms in the animal kingdom. The first time that we start to put them in their own little subgroups depends on whether they are vertebrates or invertebrates. And so what that means is an invertebrate, so this one right here, does not have a backbone. So you know, like the spine that humans have, invertebrates don't have that. Humans and any other or animal that does have a backbone is classified as a vertebrate. So there are these are the two major subgroups within the animal kingdom, and all of the organisms will fit into one or the other. And then we've got more and more subgroups within that. So we'll begin by talking a little bit about the vertebrates. This is actually going to be the central focus of this lesson. With the invertebrates, there's a whole ton of different organisms and variety that we can see in the animal kingdom and in that part of the animal kingdom, but there are just so many of them and so many names and so many different characteristics that it's not something I could really cover properly in one lesson. So I'm just going to talk about that briefly at the end, but our main focus is going to be vertebrates. These are the organisms that we tend to think of the most when we think about animals. We'll think about these something that fits into one of these five broad categories. So we know that vertebrates have a backbone, but they can still be split into five categories beyond that. And so the five categories are fish, amphibians, reptiles, birds, and mammals. Now, you guys will know from, just from your life experience and as well from probably former science class, past science classes, that the differences between these five, there are some really subtle differences which we'll talk about, but but one of the biggest things that sort of jumps out at me when I see these five words in a list is the different dependence of each of these organisms on water. And so what I mean by that is that some of these organisms need the presence of a large body of water more than others. So for example, we know that fish live in water. They have a lot of dependence on the water because that's where they live. They can't breathe if they're outside of the water. They lay their eggs in the water, things like that. But then there are varying degrees of how much a given organism depends on the water. Some of them will live in the water, some of them live on land, but they lay their eggs in the water. Some of them don't need the water at all. So we're going to talk about some of those differences as we go through these categories. So we'll begin with fish. The first point I'd like to note about fish, I mean, it's the second point I've listed here, that's a fairly obvious one, is that they live in water. Um, the reason I've included that here is that there are fish that you'll find only in salt water. There are fish that you'll find only in fresh water. So one thing to think about when you're talking about fish is that just putting them in water isn't isn't necessarily a perfect solution. There are organisms that do better in salt water and not so much in fresh water, or the other way around. So it's fairly obvious, we all know that fish live in water, but it's an important point to note that there are some fish that probably don't care whether they're in salt water or fresh water, but it is something worth considering when you're thinking about fish and where they live and what are the differences between fish that live in oceans, which are saltwater, and lakes that are freshwater. Is there it's something you can investigate on your own that, if I took this fish from here and put it in there, if I took the fish from the freshwater lake and put it in the saltwater ocean, what would happen to the fish? Why would that happen to the fish? What's different between the two bodies of these two fish? Um, so those are the kinds of things that that you'll have to think about. I've made a typo here. This is supposed to say swordfish down here at the bottom. I don't know why it says wordfish, but I was typing up this lesson late last night, so I guess I missed that. But yeah, sorry about that. The example down here at the bottom is supposed to say swordfish. Um, okay, now I ignored this point at the top. Um, And it's a pretty important point because this isn't the same. This changes between the different categorizations of animals. So one important point about fish is that they are cold-blooded, and basically what that means is that their body temperature depends on the temperature of the surroundings of the fish. So in the case of fish, their body temperature depends on the temperature of the water that they're in. If you put them in warmer ocean waters near the tropics, they'll the water itself is warmer, the fish's bodies will be warmer. If you put them way in the high Arctic, in the archipelago of islands that's way up north in Canada or something, then if you put them in the waters around there, then they'll be a lot colder because the water itself is a lot colder. And they, with seasonal changes and stuff, if you go from summer to winter and the water gets colder, the fish's bodies will also get colder. Now, the thing that's interesting about this is that when we think about ourselves and, the dangers of things like hypothermia, which isn't really a problem for you guys necessarily, depending on where you are now. But we talk about the dangers of being too cold. We especially talk about the dangers of getting too hot. If you have a fever, your body temperature goes up by a couple of degrees, you feel awful, you feel like you're burning up. It's not um, it's not like if you look at an overall temperature scale and you look at how the temperature of the water that a fish might be in changes, not even looking at the actual numbers, but just looking at how much does it change over the course of a year, it's probably a lot more than just a couple of degrees. Um, but we find that for ourselves, if our body temperature gets a little bit too high, everything starts going haywire. So it's interesting to note that for cold-blooded organisms, they don't have the same super regulated body temperature, and their temperature simply depends on their surroundings. Now, of course, because fish live in water, they breathe not with lungs, but with gills. And so with gills, basically, they still need oxygen. That's one thing that when I was first, learning about this, I didn't find it particularly surprising. I may have read it in a book or something as well, but I know some of my classmates were confused. Some of my friends were confused back when I first learned about this, that they still need oxygen. Like that's still what they're getting from the water. It's just that the oxygen isn't in, it's not like little bubbles that they're just chasing around to try and breathe in bubbles of air. They get the oxygen from the water that passes through their gills. Um, And this is something that actually the reason for there being so much oxygen in the ocean can in some ways, there are ideas that this can be attributed to cyanobacteria, which we talked about before, I think, um, because those bacteria were the ones that first learned to photosynthesize. So they would be able to take the sun's energy and convert it into their own food, and the byproduct of those bacteria was oxygen. So just the same way that we eat, we use the energy, and then we go to the bathroom and get rid of what we don't need. With these bacteria, it was like here's the water, and here's the sun. There's my very cartoonish drawing of the sun. Um, and then we have the cyanobacteria in the water. So we've got like these little bacteria here in the water. And this isn't necessarily what cyanobacteria look like. I'm just drawing, this green collection of stuff, and we'll say that's the cyanobacteria. But so suppose you got the cyanobacteria there. So the sun's rays come down uh, through the water to the cyanobacteria. They absorb that energy, turn it into their own food, so that makes them happy, because that's what they really need. They don't just use the sun's energy directly. They need to convert it into something that they can use, but then they have a byproduct that they don't really need anymore, and when they're done with using that energy, their byproduct was oxygen. Um, and ooh, that line's going all over the place. Um, their byproduct was oxygen, and so that process and that byproduct being oxygen meant that there was more and more oxygen in the ocean as more and more of these bacteria began to photosynthesize. So over time, the ocean became so filled up with oxygen that then the oxygen didn't really have any place to go within the ocean. So over time, as the oxygen O2 is the oxygen that we had. So we've got dissolved oxygen just floating around the ocean. And as more and more of these bacteria photosynthesize, there's less and less room for new oxygen down here in the ocean. So instead of trying to crowd its way into the ocean where there's no room, the oxygen simply started to escape into the atmosphere. And that's, I'm not sure if it's the most accepted theory, but this is one of the ones that I heard when I was younger, that this is possibly the reason why we have so much oxygen in the atmosphere today, is because of basically these little bacteria guys that learned to photosynthesize, and they filled up the oceans with oxygen, and then they filled up the atmosphere with oxygen because the oceans were so full of it. Um, but yeah, so they are still trying to get oxygen, and there's plenty of oxygen in the ocean, and that's what they use their gills for, these fish. Um, Now, fish do hatch from eggs. For anyone who's seen Finding Nemo, that won't be much of a surprise. But yeah, so basically they hatch from eggs, and those eggs have to be laid in the water. The fish live in the water. They can't really survive out of the water. It makes sense. Um, Now, for fish, they might have different structures within their bodies. Some of them will have skeletons that are made out of bone, and some of them will have skeletons that are made out of cartilage. Now, if you look at like a human skeleton, we've got bones and cartilage. We've got some parts of the body that are made out of bone, and then some that are made out of cartilage. So they have different purposes, but some fish will have skeletons that are predominantly cartilage, whereas we don't really see that for ourselves. We see lots and lots of bone and then cartilage in certain areas. Um, with fish, you might find some that have entire skeletons made out of cartilage. And there are tens of thousands of species. I've put a statement similar to this on all of the different slides. But basically with fish, there are an immense number of species, and honestly, we don't know enough about the different types of fish that you can find in the ocean. Uh, just a few examples of organisms that fit into this category. I didn't want to say, this type of fish, this type of fish, this type of fish, this type of fish, because that's what we're talking about. We're talking about fish. So I've given one, swordfish, and of course that's the one I spelled wrong, wordfish. But also eels and seahorses can fall into this category. So the next one is amphibians. Um, these ones are also cold-blooded organisms, so their body temperature depends on the temperature of the surroundings. Um, so the interesting thing here is that we're going to have to look at the next few points sort of all together. We'll look at these, I was going to say three, but let's say these 4 points all together. So what we've got is, um, let me draw, so we got water and we got land. Okay, so we got land up here and we got water over here. So what we've got is the eggs are laid in the water. So I'm just going to drop them somewhere in the water. We've got eggs here in the water. So what's interesting is that the eggs will be in the water, the babies are born in the water, and they breathe through gills, just like fish. So if you think about frogs, I've listed frogs down at the bottom as an example. When they're babies, when they're tadpoles, they are basically like fish. And sometimes the babies of these amphibians will be very similar to fish in more ways than just the way that they breathe, but then they undergo this transformation um, when as they start to get a little bit older. Okay, so there's my drawing of a tadpole. So we've got the eggs in the water, and then it goes on to the baby is born, and then we've got a tadpole that's still in the water. But then as they reach adulthood, they develop lungs. So adults, I can't really draw a frog, but I'm not even gonna try. When they're adults, they live out here on the land, and they breathe air just like just like we do. Um, and so it's interesting that that amphibians are still somewhat dependent on the water, because that's where they have to lay their eggs and that's where the babies are born. But adults don't need the water the same way that the babies do, and they don't need the water the same way that fish do, even though they all started out their lives pretty similar to fish. Um, and what's more is they've got this neat extra thing, which is that they don't have to just breathe oxygen the way we do. Um, if they keep their skin moist enough, they can actually take in extra oxygen through their skin. So basically breathing through your skin, which is maybe a little bit of a weird concept for us, because that's not something we can do, but it's an interesting thing to point out. Um, Amphibians tend to consume insects. They basically eat insects as their main diet. So you might see the word insectivore thrown out. So we've talked about herbivores and carnivores a little bit. Um, Herbivores are animals that eat plants, and carnivores are those that eat meat. Um, and then omnivores are the ones that eat both. Uh, but because amphibians subsist almost entirely off of insects, we can call them insectivores. So the ivore ending is basically what it eats. So this part right here is basically what it eats, and then the first part of the word is what does it eat. Um, so it's like insect eater. Um, and for amphibians, there are thousands of species. Um, it's from the book I was reading that I used to love this one book years ago about that talked about these different classifications of living things and stuff. and it sounds like there are much less species of amphibians than there are fish, but there are still thousands. And some examples are listed at the bottom there: frogs, salamanders, toads, newts, lots of different ones. So next up is reptiles, which a lot of people, when I was in school, this was something that people tended to confuse um, with amphibians sometimes, just I guess because of, I don't know, some of the types of organisms, I guess, are more similar to each other than they are to fish or to mammals or something. So for example, if you just take a look at the bottom here, where we've got things like lizards and turtles and stuff, and especially things like turtles, where we might associate them with water more than we would associate birds or mammals with water, but we also associate them with land a lot more than we would fish, let's say. So um, it seems like it's not super unreasonable to um, mix up some of the reptiles and amphibians, but they do have some similarities. So um, for one, there are thousands of species of them, but also same as what we've seen before, reptiles are generally cold-blooded, just like amphibians and just like fish. So their body temperature depends on the temperature of their surroundings. But with amphibians, or with the babies, they're in the water. With the adult amphibians and with the reptiles, they don't live in the water. Um, so, or like they don't need to live in the water as a rule. To be a reptile, you don't have to live in the water. Um, so their body temperature can just depend on the temperature out on land and stuff, instead of the water temperature. Because if they're not in the water, their body temperature is still affected by the environment around them. It's just the air and the land instead of the water. They don't need to lay their eggs in the water, though. For reptiles, that's the difference. They still lay eggs, but those eggs don't need to be in the water the way they were for amphibians. Reptiles breathe through lungs, so that sounds more and more similar to us, that we don't need water in order to give birth to offspring, and we breathe through lungs, and we can be, we're not herbivores or carnivores. We humans in general are omnivores, but there is variety in reptiles. You'll find some that are herbivorous, that they only eat plants. You'll find some that are carnivorous and they only eat animals. Um, so there are some differences between reptiles and amphibians, but they definitely have some similarities as well. Notably the cold-blooded nature and the fact that you can find lots of them still in the water. But hopefully you can see as we're progressing here that especially in these first three, there's been less and less dependence on the water, right? With the fish, they're born in the water, they live in the water, they die in the water. With amphibians, they're born in the water, and as they grow up, they live on the land. Reptiles don't need to be in the water in general. You might find reptiles in the water, but they don't need it in order to survive. Like with a reptile that wants to be in the water, that's fine. That's basically its choice. But for an amphibian, it doesn't have a choice. If it doesn't lay its eggs in the water, that the babies won't survive. So those are some of the differences between these three categories that we've talked about so far. So now we move on to our fourth category, which is birds. Now this is for the first time we're seeing an organism that is warm-blooded. And so what warm-blooded means is that there are some processes that are taking place within the body of the bird that regulates its body temperature. So it keeps its body temperature at a roughly consistent temperature. Um, at a roughly consistent level, regardless of its surroundings. So if it's cold outside, the body will have to work a little bit harder to keep it warm. When it's really hot outside, and if it's warmer than the bird's body wants to be, then the body has to actually put in work to cool it down. So The body, it's all just like with us. It's not something that the bird necessarily has to think about. It just happens. Um, but this is the first time that we see an organism whose body temperature does not simply depend on the temperature of the surroundings. Now, of course, with birds, we've got some obvious points. They hatch from eggs. That's something that we all tend to think about. They don't have teeth, but they have a beak or a bill or something like that, which they can use instead. They don't have front legs, but they have wings. And having wings, unfortunately, for some of these birds, does not mean that they can all fly, but I mean, it sounds like it would be pretty cool to have wings. Um, so that's something that they've definitely got going for them, especially for the birds that can fly really well. But even for those that can't, so for example, penguins that can't fly, they are still excellent swimmers, and their body structure might be that of a bird, but they aren't built for um, being great in the air, but they are excellent swimmers. They've got their body basically is equipped with a bunch of flippers that they can use in the water um, to find their food and stuff that way. So it is interesting that while birds might have these similar body structures and they might have wings and stuff, they might not all have feathers. They might not, or like they generally have feathers, but you'll find ones where they've got a lot more prominent feathers, like a peacock compared to a penguin. You don't think of penguins as having these big, beautiful patterns in their feathers, but you do think that for a peacock. And there are, some birds where the feathers might be really, really small, so it doesn't really look like they've got feathers, but they're there. And then you'll have other ones where it's really easy to tell, like with parrots or with owls or something. It's really easy to tell that they do have feathers. Um, Once again, there are thousands of species, and just like we've seen before, they can be herbivores or carnivores. So you'll find some birds that will consume other animals, and then you'll find some that simply don't. So now we come to the last one, which is mammals, and this is where we are. You can see down here at the bottom, we've got examples. Um, we've got humans down there in those examples. So mammals are warm-blooded. So this is something that we've talked about a little bit before. So humans, this one is something that we can think of for humans ourselves, because I mean it applies to other mammals as well. Elephants and chimpanzees and mice and stuff. Um, Mammals are generally born live, so we don't need the mother to lay eggs from which we would then hatch. We're just born alive into the world, and that's it. We're alive. We're living. No eggs necessary. Um, we are the only animals with hair. I remember when I was in my grade 11 or so biology class, my teacher said, "What makes mammals different from all the other animals?" And people were saying things like, "Oh, well, we're warm-blooded," or "We have this," or "We have that," and uh, there were some things that it sounded like, "Oh, this is unique to mammals," but then turns out there's some like amphibian or something that also has or doesn't have whatever we had just claimed. And it turns out that the answer for one of the things that separates us from everything else is that we're the only animals with hair. Now, other animals might have things that function similarly. They might have like feathers or something with birds, or scales in the case of reptiles and stuff. That sometimes they have a function for protection, or sometimes maybe it's something to do with regulating their temperature, or they have each of these organisms have their own way of sort of dealing with these challenges. And for mammals, our way of dealing with that is with hair. Um, and babies drink the mother's milk, um, and that's another defining characteristic of mammals. And once again, there are thousands of species. So now we'll talk just briefly about invertebrates. Um, so these are animals that don't have a backbone, so they don't have spines like we do, but they might have some other way to protect themselves or to give their bodies some sort of structure. They might have something like a shell, they might have an exoskeleton, which is basically like armor that's just part of the body, um, to protect themselves from from predators and from the outside world and stuff. Um, or they might have nothing whatsoever. So if you think about something like a jellyfish, um, they they just have their squishy bodies and the tentacles and stuff just kind of hanging out, and they don't really have any sort of protection for it. There's no shell, there's no exoskeleton, there's no armor, there's nothing like that. It's just they're just there, and they're these big squishy things, and they might have their other defense mechanisms, like with jellyfish they can sting their um, predators, but they can get pretty creative. Now, one of the reasons that I've been highlighting the thousands and tens of thousands of species for the different categories of vertebrates is because when it comes to invertebrates, the variety is so much greater. There are millions and millions and millions of species of invertebrates. And I'm just going to, on the last slide now, in a second, I'm just going to show you a list of a whole bunch of different types of invertebrates. We're not really going to talk about them. This lesson is just about finished, but we'll just give you a brief overview. So here are some examples of invertebrates. There are plenty of uh, different ones that are really, really fascinating, and you can go and read about them on your own if this is something that interests you. Um, I had this book, I think it was the same book that I was talking about before, that talked about things like uh, different classifications of invertebrates, and there are so many different types of worms that show up there. So I've listed one here. I've got flatworms. There are also roundworms. There are segmented worms. There's velvet worms. There's just a lot. There are a lot of different worms out there. Sponges, so like sea sponges and stuff would be considered invertebrates. Mollusks, echinoderms, arthropods, corals. There's so many different kinds of organisms that are invertebrates, and some of them will have no protection. Some of them will have a shell. Some of them will have um, some of them will have the ability to sting, like a jellyfish. Some of them might have an exoskeleton. So there are a whole bunch of different ways that these organisms can take care of themselves and protect themselves from their environment, but the one thing that they all have in common is that none of them have a backbone. So that's about it for what I wanted to cover in this lesson. I am recording this on a Thursday, which is later in the week than I would have liked to record this because we meet every Friday. So if you haven't gotten a chance to watch this before our meeting tomorrow, don't worry about it too much. Just as long as you can watch it like over the weekend or early next week or something, that'll be great. I'm hoping I can record the next science lesson and the next sort of batch of lessons um, all over the coming weekend so that I can put them out by Monday or Tuesday. But yeah, if you have any questions about this, let me know. Whenever you end up watching this, if you end up watching this after our meeting this week, then we can talk about it next week. Have a good one.